by 4. And the slope we said was 0. So that gives me y minus 4 equals 0 times x minus 5. Okay? And the last one. At 7. F prime at 7. What is that approximate? Negative 4. Let's see. 1, 2, 3, 4, and 1 to the side. Is that a good one?
How about negative?
How about negative 3?
Better.
How about negative 5?
Always a better one.
I just went with the first one, so what was that one? Negative 4? Is that okay? Or am I wrong?
Would you say there's a better one?
You said there's no wrong answer.
There's no wrong answer, right? There's just better estimates.
I'll solve it.
Well, I mean, that one was really odd. No, that just wasn't as good of an estimate.
Don't worry.
Alright, so what can we tell about the function here?
Decreasing.
The function is decreasing because the derivative is negative. What's another way of saying derivative? The slope of the tangent line. Okay, you gotta understand your justifications because in calculus, you have to justify all your reasoning. You can't do it like in pre-cal where you would just say, oh, it's increasing. You gotta tell me it's increasing because the derivative is positive or the slope of the tangent line is positive. Okay? So what would be my point here? 7, negative 1. My slope we said was negative 4 approximately. So my equation is y plus 1 equals times. Beautiful.
I love
Come on, that was weak,
I love
guys.
math.
Beautiful.
I love math.
All right, this is going online. You gotta make it count.
I love math.
All right, so let's put it all together and let's see if we can use the values that we get for derivatives to make predictions about the original function. Okay, so we figured out that when the derivative was positive, what was the original function doing? We got positive numbers here. What was the graph doing? Increasing, right? So you can say the graph is increasing or f is increasing because the derivatives are
positive.
positive. When was it decreasing?
When they're negative.
So the function is decreasing because
The derivative is a negative
because the derivatives are negative numbers. Very good. Okay. How could we say we have a maximum? What had to be true first?
First, they were increasing on one
The derivative had to equal to what? To 0. That's the first thing, right? And
One side has to be increasing, one side has to be decreasing.
okay, so remember calculus is the study of what? Change, right? So the derivative has to change from what? Positive to negative in order for it to be a maximum, right? The function has to go from increasing to decreasing. You understand? Yes? So when we talk about derivatives, you're going to say positives or negatives. And when we talk about the function, you're going to say it's increasing or decreasing, or it has some maximum, okay? And you're making that justification because of the sign of the derivative. Alright, so let's see here. Based on what you observed on the table on the previous page, what inferences can you make about the value of the derivative and the behavior of the graph of the function? Okay, so what is the derivative telling me about the function? Okay, so it tells me a couple of things. The first thing, let's look at a condition. So if the derivative at that number is greater than 0, meaning it's what? Positive, what would that tell me about the graph? So then we can say that f of x, the original function, is increasing at that value, which is what? A. Okay, so if the derivative is positive at a, then that means the graph is increasing at a. I don't know what's happening anywhere else, just at that value. Understand? Right. The second thing we figured out was if the derivative was what? less than 0, meaning it's what? Negative, then what was happening to the graph? Very good, it was decreasing at that particular value. Yes? Alright, there were two other things we discovered how to find, and those were the maximums and the minimums, okay? So, the function f of x, the original graph, has a relative max if, what had to be true first, Caitlin? It was positive, or it was equal to 0? Very good. So the first thing has to be true is that the derivative has to be what? 0. Now it could be a maximum or it could be a minimum. So the first thing is that it has to equal to 0. And what's the second condition? The derivative changes, very good, from positive to negative. Okay? So the derivative has to be a positive value, and then it has to change to a negative value on the other side of that 0. There would be a max. Good? Right, and the last thing is we know that the function has a what? Relative min if what? The derivative is equal to 0 at a, and that derivative changes, beautiful, from negative to positive, like Pitbull. Okay, he changes negatives to positives. That's why he's become so famous. You need to listen to that song? You really do, so that way you can change all your negatives in your lives to positives. I'll look for it right now. Good? Alright, so I'm going to pass out your assignment, and I want you to work on numbers 1 through 7. So you're going to work on numbers 1 through 7 on your assignment, okay? Sounds good? Alright, awesome.
Luis. Luis.